Welcome to the first video in the Chapter 1 Part B series. In this video, we're going to focus on significant figures. So the first few points are a quick summary or review of what you've already learned from videos or readings. So significant figures are going to tell us the precision of the instrument that we use to record those values. So remember that you can have either more precise or less precise balances or rulers or anything like that. And so significant figures will tell you how precise that your balance or your ruler is. Now, the rules for significant figures, the first one and the easiest one is that all non-zero digits are considered significant. Okay, so the tricky part are your zeros. Now, if the zeros are what we call leading, if they come before any non-zero digits, then those are never significant. Okay, if the zeros are held captive between two or more non-zero digits, so if they're sandwiched between non-zero digits, then those zeros are always significant. And the ones that can go either way are our trailing zeros. So the trailing zeros are going to be the ones that appear after your last non-zero digit or your farthest non-zero digit to the right. Okay, if there is a decimal present anywhere in your number, then those trailing zeros are always going to be significant. If there is not a decimal present anywhere in the number, then those zeros are going to never be significant for the purposes of this class. Okay, but today, in this video, I'm going to use a trick to help you determine sig figs. So what we're going to do is we're going to underline the leftmost non-zero digit. We're going to continue underlining to the right until the last non-zero digit, and that will catch all of our non-zero digits and our sandwiched zeros. And then we're going to ask one question. Is there a decimal present in the number anywhere? If there is, then we're going to keep underlining and include all the zeros to the right of the non-zero digit. If not, we're going to stop at the rightmost non-zero digit. So what does all this mean? Well, we're going to practice some examples here. Okay, so our first example, looking down at number 5A, how many significant figures are contained in 38,700 grams? Okay, so I'm going to take my pencil and I'm going to underline starting at the leftmost non-zero digit. And then I'm going to keep underlining until I get to my last non-zero digit. Okay, so all three of those are definitely significant. And then we have to ask about those zeros. So remember, the question I have to ask, is there a decimal anywhere in that number? Doesn't matter where it's at, but is there a decimal? And I do not see a decimal, okay, anywhere in this number. So if no, I'm going to stop at the rightmost non-zero digit, which means I'm going to stop at that 7. Okay, so I have underlined 1, 2, 3 numbers, which means that I have 3 sig figs in that number, where SF stands for sig figs. Okay, B, again, we're going to start from the leftmost non-zero digit, and then I'm going to underline all the way until I get to the rightmost non-zero digit. Now, there's no other numbers off to the right or to the left of what I've underlined, which means that at this point, everything is significant. And so I can go ahead and count up those sig figs. And I've got 1, 2, 3, 4, 5, 6, 7 digits that I've underlined. So that is 7 sig figs. Okay, part C is a little tricky. We've got scientific notation here. Okay, so with scientific notation, you always want to ignore the times 10 raised to the power. So with scientific notation, ignore the times 10 raised to some power. So we're just going to mark that out, and we're going to focus on what we call the coefficient. Okay, again, starting with that leftmost non-zero digit, that's the 9, we're going to underline until we get to the rightmost non-zero digit. And so we're going to underline all the way to that 5. And then ask our one question, is there a decimal anywhere in that number? And the answer is yes. So first 2 were no, we didn't see any decimals, but yes, we see a decimal right here. Okay, and so because I see that decimal, I'm going to keep underlining and including all zeros to the right. So I'm going to keep underlining out until I get to that last 0. So this time I have 1, 2, 3, 4, 5 sig figs. Okay, part D, we're going to start at the leftmost non-zero digit. So notice how I'm ignoring what I call my leading zeros. And then I'm going to keep underlining until I get to my rightmost non-zero digit. And there's nowhere else for me to go to the right, so I'm done. And this time I underlined 1, 2, 3 digits, so that is 3 sig figs. Okay, and last one, again, find that leftmost non-zero digit, go to the rightmost non-zero digit, stop, ask the question, is there a decimal? And yes, there is. Doesn't matter where it's at. Yes, there's a decimal, so I keep underlining all the way to the end on the right. Okay, and that gives me 1, 2, 3, 4 sig figs. 4 digits that I underlined. Okay, now the one thing I didn't cover yet are sig figs for exact numbers. In this class, there are several types of exact numbers out there, but the ones that we focus on are the metric unit conversions. So when you look at your conversion factor sheet and that is given to you, okay, on exams or something similar to this, here, all of these conversion factors that we see listed, we're going to assume that all of those numbers are what we call exact numbers, which means that they will not contribute to the number of sig figs for our answers in our calculations. Okay, so exact numbers always have infinite sig figs. And so we're going to ignore those when we're doing calculations. And an example that I have listed here, 1 centimeter equals 0.01 meters. Okay, so both of those would be considered exact, and so that 1 is what we call infinite sig figs, and that 0.01 is also infinite sig figs. Okay. Now we're going to move on to rounding to the proper number of sig figs. So the important thing here is that we have to keep the same magnitude when we are rounding by replacing rounded numbers with zeros. And the example that I have is if you have $5,432 in your bank account, and I told you to round that to 1 sig fig, well, the 1 sig fig would be the leftmost non-zero digit, which would be that 5. But if I simply wrote it down as 5, then I would be telling you that you had $5 in your bank. And I know that that would upset you, right? You have about $5,000 in your bank. Okay, so even though those trailing zeros may not be considered significant, they can still be important when it comes to magnitude. So if I want to round 5,432 to 1 sig fig, I keep the 5, and then I have to replace all of my other numbers with zeros. Okay, and then that gives me the about $5,000 in the bank. So let's try some examples here. We're going to round off each of the following values to 2 significant figures. Okay, so in order to do that, we're going to start with the leftmost non-zero digit. And if we want 2 digits, then we want to take the digit next to it. And then we're going to look to the digit next to that to decide whether we round up or down. Right? So in this case, that 4 next to that 5 told me to round down to 5,000 instead of up to 6,000. So here again, that 0 tells me to round down, and I'm left with 5.0. Now, if we want to include the uncertainty, typically what we will do is add plus or minus, and then we're going to add a 1 in the decimal place that's shown at the very far right, which in this case is the tenths place. So this would be 5.0 plus or minus 1/10 of a millimeter. Okay, B, again, we're going to start with the leftmost non-zero digit and take one extra digit beside of it to get 2 sig figs. Look next to that, and that 8 tells us to round that 3 up. So it becomes 6.4 instead of 6.3. Okay, and then we do have to keep the times 10 to the third. And if we wanted to include uncertainty here, the best way would probably be plus or minus 0.1 times 10 to the third liters. So again, right where that last digit is, we just replace it with a 1. Make sure to include the scientific notation and then add our units onto the end. Okay, and then the last example, we have 517. 2 sig figs would be the 5 and the 1. Look to the 7, tells me to round that 1 up to a 2. But I can't stop at 52, right? Because if I had $517 in the bank and then the banker told me I only had $52 in the bank, I would be upset. No, I have about 520. So remember that I have to replace that 7 with a 0. Okay, I didn't have to do that in parts A or B because we were after the decimal. So whether I have 5.0 or 5.00, that's still $5, right? That's still 5. But in this case, I have to add the 0 to keep the magnitude. Okay, and then because the tenths place was where I stopped in significance, that would be plus or minus 10, and then grams per milliliter. Okay, but again, probably in your homework platform, you may not even need these plus or minuses. They're just there to show you what uncertainty looks like. Okay, and then the last part about sig figs are multiplication and division. So we want to use the number with the least sig figs to determine the number of sig figs in the answer. Okay, in this first example, I have 5.63 times 10 to the second, and I've got to figure out how many sig figs are in that number. So if I start at the leftmost digit and trace across and ignore the scientific notation part for sig figs, then I find that I get 3 sig figs in this first number. Okay, and then for the second number, again, both of those non-zero digits count. That's 2 sig figs. And then if I put this into the calculator properly and include those scientific notations because they do count for magnitude, my calculator should say something like 4.166 times 10 to the 6th. Well, I want to cut that off at the least number of sig figs used. So that would have been 2 sig figs in that second number. Okay, so I only want 2 sig figs in my answer. Look next to the 1 and decide to round that 1 up. And so I get 4.2 times 10 to the 6th as my final answer. Okay, and then in the second one, again, that top number, all 3 of those count because there is a decimal and that 0 is to the right of the non-zero digits. So that is also 3 sig figs. And then below it, we've got 13.48. That's going to be 4 sig figs because they're all non-zero digits. So the least in this case is going to be 3 sig figs. All right, so my final answer should only have 3 digits. And then the final number is 2.07715. Round that off, becomes 2.08.